And the final one, oh, I'm so tight for space. I think I see whether can I squeeze the thing. Yeah, squeeze. I'm going to squeeze. Eugene, did I do anything or no? I don't think so. I did anything. Oh, I did. Sorry. Stupid me. And the last one. Okay, the last column is you multiply horizontally what's going on. So it's W, D, and Y bar. Okay. So this is equal to 32, 123, 160 times 60, 96, 123, same thing. Okay. Then the last column, you do the summation. Okay, you do the summation for the area and you do the summation of the W, D, Y bar. Okay, so 320 plus 160 plus 160 is equal to 640. Okay, and then 9600 times 2 plus 132, 123 is equal to 51. No, 96, 123 times 2 plus by 32, 123 is equal to 224. Okay, so the Y bar is equal to the summation of width, depth, small y bar divided by the summation of the width and depth. So this is equal to 224, 123 divided by 6,400. Okay, so 224, 123 divided by 64 is equal to 35 millimeters from the top. Okay, so what we just found out is the distance from here to here. Right, that distance over there is 35 millimeters. Okay, so this is how you formulate or how to find the centroid. Okay, then the next thing is your second moment of area. So I ZZ is equal to width times depth cubed over 12. Now the over 12 is because it is a rectangular. Okay, plus by area multiplied by y bar minus, so that is the global centroid divided by the individual centroid, and you square the whole thing. Okay, so this is a formula that some of you have seen it before, some of you have not seen it before. Okay, now I am just going to look at the table. Okay, I repeat again, I am just going to look at the table and I'm going to calculate the second moment of area for 1, 2, and 3, even without looking at diagram. So I'll demo to you. Okay, so I'm going to cover off the diagram. I cannot cover off the diagram. Okay, wait, there's a way of doing this. Hold on. Yeah, these notes are definitely going to be posted. I always post my notes, you cheeky sort. Don't you agree? I always post the notes. I'm going to show you this, okay? I'm going to show you this PowerPoint. Bear with me, okay? 1 second. Okay, I am only going to look at the table, okay, to form my second moment of area by just looking at the table, okay? And I think this is good practice. You will never go wrong. Once your table is right, you're zoned in, okay? So IZZ1 IZZ1. I can't see. Oh, hold on. Cheeky sort. Yeah, stupid sort. But anyway, I can't see it. Okay, so it's equal to 160 with multiplied by 20 power cube divided by 12 plus by cross-sectional area of 3200 multiplied by big Y bar is equal to big Y is equal to 35, small Y bar is equal to 10, the whole thing squared. Okay, so this will be equal to 160 times 20 power 3 divided by 12. So this is equal to 320 times 10 to the power 3 divided by 3 plus by 35 minus 10 squared times by 3200. So it's equal to 2 times 10 to the power 6. So this will be equal to 320 power 3 divided by 3 plus by 2 power 6 is equal to 2.107 times 10 to the power 6 millimeter to the power 4. So this will be equal to 2.107 times 10 to the power minus 6 meter to the power 4. Okay, change everything to meters. Okay, then I go into IZZ2. This will be equal to 20, 80 cube over 12 plus by the cross-sectional area is 1600. The Y bar is 35 minus by 60, so thing squared. Okay, so 20 times by 80 power 3 divided by 12. So it's equal to 2560 times 10 to the power 3 divided by 3 plus by 35 minus 60 squared times by 1600 is equal to 1 times 10 to the power 6. So this will be equal to 2560 power 3 divided by 3 plus by 1 power 6 is equal to 1.853. Yeah, 1.853 times 10 to the power 6 millimeter power 4. And this is equal to 1.853 times 10 to the power minus 6 meter 4. IZZ2 is equal to IZZ3. So this will be equal to 1.853 times 10 to the power minus 6 meter 4. Right, I did this without looking at the diagram. Okay, I just follow the what? I just follow the table. So what is the trend I'm trying to show you? Okay, so if you look at the trend over here, this comes to here, this comes to here, this comes to here, 35 comes from here, and 10 come from here. Can you all see the trend? Okay, then I will do another one. So the one below, same thing. Okay, the one below. So the one below is 2 and 3. So it's the same thing. You see, this comes to here. This is good practice. Okay, why I do this? Because when I do, you can write a program out from this, isn't it? You can use Excel to write program to how to formulate your second moment of area. That's how I create this for your marking scheme. Because in your term test or in your quizzes, no one gets the same number. Okay, there you go. I hope y'all can see a trend. Okay, y'all can see a trend. And this way, I know the solution manual don't do this. Okay, you do it this way, the possibility of getting this wrong is very, very small. Okay, I would strongly suggest that you all use this. Okay, so from here, we can calculate our IZZ. Okay, so it's equal to IZZ1 plus by IZZ2 plus by IZZ3. Okay, So IZZ1, we know that is what? 2.107. Okay, so 2.107 times 10 to the power of minus 6 plus by 1.853 times 10 to the power of minus 6 plus by 1.853 again times 10 to the power of minus 6. Okay. So this is equal to 2.107 power minus 6 plus 1.853 power minus 6 plus 1.853 power 1.853 power minus 6 is equal to 5.813 times 10 to the power minus 6 meter 4. Okay. So where we are now we have calculated, we have done our centroid, we have done our second moment of area. Okay, now we are going to find our first moment of area. Okay, we're going to find our first moment of area. Okay. So what we know, so let's find the first moment of area at point A. Sorry, our shearing stress at point A. So it's equal to Vy over Izz, right? Qz divided by T, right? So we know that our centroid is here. We calculate this out already. Hey, what happened to my mouse? It got missing. We know that our centroid is here, right? So this is our centroid. And we know that this is where we have our 90 times 10 to the power 3 is our Vy, right? And we want to find the stress at A. Okay, we want to find the stress at A. Okay. So the area that we are going to find to take, as you can see, okay, we apply the rules that this is or before I go on, we know that Vy is equal to 90 times 10 to the power 3 Newton. We also know Izz is equal to 5.813 times 10 to the power minus 6 meter 4. This is because of rule number 1. Regardless of point A, point B, point alpha, point zeta, whatever, V and I are always constant. Okay. QZ, the first one. So point A is there, right? So we know that one of the rules that we say that this is our datum, our geometric datum is here. And our analysis direction is going towards the datum. Analysis direction. Right? So this is the area that we're going to take. Okay? That is the area we're going to take. Okay? So now you know how to calculate your QZ. So QZ is equal to the width times by depth multiplied by y bar. Okay. Now the y bar is from where? Y bar is from the datum. Okay. Y bar is from the datum. Okay. So your width is equal to 0.16. Your depth is 0.02, right? And then the y bar, no, let me write it this way, that is less confusing. So 0.16 multiplied by 0.02. And then your y bar, right? Y bar is equal to what? So we know that the distance from here to here is what? 35, right? We know the distance from here to here, right? At the area, the distance from here to there is 10 millimeters, right? So y bar is equal to 0.035 minus by 0.02 divided by 2. Right? To get 10 is 20 divided by 2. Okay? So this will be equal to 0.035 minus by 0.01